Dana. There you go. Hi, Dana.
Hi, Mark. Hi, Adam.
Hey, Dana.
I see we already have some attendees.
Adam, do you want to pull up the presentation to get that ready?
I think I need to be able to do that, Dana.
Oh, did you not get a link from our IT director today?
He did, but he had said there was some things for you to do.
Oh, let me just check if I might have missed the email.
I did not get a direct link like Mark did, though, to like automatically do it.
Yeah, you are a panelist, Adam, so.
So I saw your email, Adam, but I didn't see the response from Ryan. Yeah,
It said start the meeting as the host.
okay,
It says in the meeting controls, click participants,
okay,
and then hover over the name of the participant who is going to be co-host and choose more.
okay.
And then
Make
click.
co-host.
Yep.
Okay. Phew. There we go. I see it.
Hey, Dan, do you want to start right at 6 or do you want to give a few minutes for people to join in? Oh, you're muted.
I say we can get started at 6, which is just turned 6.
All right. So I'll start. All right. Thank you, Dana. So thanks everyone for joining us tonight for the public hearing for the comprehensive wastewater management plan for the city of Gloucester. So just a brief overview of what we plan on presenting tonight. We're going to go over briefly for the project team, reasons for a comprehensive wastewater management plan, otherwise known as a CWMP. You'll hear it referred to as that throughout the presentation. We'll go over the project approach, and we'll discuss each of the 3 phases with the recommended plan, and we'll touch upon funding and financing, and then we'll have questions and discussion at the end. I believe the chat function is turned off, so the goal of this public hearing is for public input. So we'll try to answer your questions the best we can this evening. If not, all the questions will be recorded and will be included in the meeting minutes within the final CWMP document. So we ask that you hold any questions to the end of the presentation. My name is Mark Macchio. I am a project manager with Wright Pierce, and with me this evening is Adam Higgins, who was the project engineer for the project. A comprehensive wastewater management plan is a wastewater management tool, a plan that the city can use as a guide over the 20-year planning period. It not only looks at the existing wastewater collection system and treatment, but also unsewered areas as well. For the unsewered areas, it evaluates them in order to determine if additional wastewater treatment measures are warranted for those areas. For the wastewater collection system, the existing pipe network and pump stations were evaluated, as well as identifying sources of infiltration inflow, which were presented as recommendations in the capital improvement plan. The city's water pollution control facility is somewhat unique because it only has primary treatment. The city recently received a renewed national pollutant discharge elimination system permit, which requires the treatment facility to be upgraded with secondary treatment. And as part of the CWMP, we looked at secondary treatment alternatives as well as aging equipment that needs replacing. Having a CWMP in place allows the city to potentially qualify for low interest SRF loan funding and other funding and grant opportunities, which we'll touch upon towards the end of the presentation. Throughout the project, Wright Pierce has worked with the city and Mass DEP through workshops, meetings, and reviews. Leading up to the CWMP, the city has been very proactive in evaluating their existing wastewater infrastructure. They previously have done the utility master plan, which looked at and evaluated the city's wastewater and stormwater systems. They then did the asset management plan, which looked at the collection system and water distribution system, as well as a detailed evaluation of their wastewater pump stations. And they've performed an evaluation at the water pollution control facility, which looked at existing process and equipment and structures, as well as did a preliminary view of secondary treatment alternatives. All 3 of these projects, Wright Pierce is fortunate enough to work with the city on, and they are also included in the appendix of phase 3, of the draft phase 3, which is available on the city's website. CWMP is made up of 3 phases, with each phase building on to the next, culminating into the 3rd phase, which is the 20-year recommended wastewater management plan. And with that, I'm going to pass it to Adam, who is going to go into more detail for each of the phases.
Thanks, Mark. We're going to cover a lot of information over the next 40 to 50 minutes or so, walking through each phase of this presentation. or CWMP. So phase one, we take a look at the existing conditions within the city, both the unsewered areas, the existing sewered area, and also just a general view of the city of Gloucester as a whole, and even parts of the surrounding regions. Part of the existing conditions takes a look at the what we call Gloucester metrics, which involves any planning documents or proposed developments the city has in the queue, population forecasts so we can understand if the city is growing or declining in population. We developed study areas of the unsewered areas in the city and performed a wastewater needs assessment on those study areas. So let's talk a little bit more about those metrics, what goes into them. So we look at population breakdowns, demographics. Of particular interest is land use and open space and watershed planning, also water quality and zoning and planning department information, and natural environment such as protected habitats. Focusing on the existing wastewater system, we did a condition assessment of both the collection pump stations and water pollution control facility. So what makes up those parts and pieces? Well, the collection system's made up of 60 miles of sewer pipe, 29 pump stations, the pollution control facility itself, and that sewer collection system serves around 83% of Gloucester residents. There's also flow that's received from Essex and Rockport, and the treatment facility itself has a NIPD's permit limit, average daily flow of 5.15 million gallons per day, and has the potential to increase that average daily flow to 7.24 million gallons per day. The renewed NIPD's permit had the 301 waiver, which allowed the city to operate as a primary treatment plant since its inception. That waiver was removed, meaning the city now needs to comply and add secondary treatment to the facility. If the city chose to increase the permitted flow limit from 5.15 MGD to 7.24, a capacity increase would also be required. The existing tanks and pumps, for example, may not be sized appropriately for that additional flow. So this is a map of the existing wastewater collection system. You can see here, and I hope you can see my cursor on the screen. The green lines are gravity pipelines. The red lines are force mains. The yellow boxes are the 29 pump stations I mentioned. And this green box here is where the treatment facility is located. You can see the collection system itself is mostly in the center of the city, with some branches going out to Essex, Rockport, and the northern part of the city. So aside from the existing wastewater collection and treatment systems, we also take a look at the unsewered areas. So those parcels, buildings, et cetera, property in town that don't have existing sewer connected to them. The typical method of treating wastewater at those locations would be an on-site subsurface wastewater disposal system, also known as a septic system. See the figure here, building sewer is connected to a tank. The tank then has clarified wastewater flow into a distribution box, which then goes out through a drain field and then eventually to groundwater. So about 17% of the residents of Gloucester are on on-site systems, but about 63% of the land in Gloucester is actually served by these systems. So quite a large area. This is typically a cost-effective solution, especially for those areas that are not close to an existing sewer, but they do require ideal soils. That way the wastewater has a chance to percolate and receive treatment before it gets to groundwater, adequate depth to groundwater or bedrock. That way there's no interferences and has that time for treatment before it gets to groundwater, and an adequate parcel size. So we mentioned the existing sewered area. That's the colored orange parcels that you can see here, which lines up with the collection system figure we had before. And anything not connected to sewer in the beige, we divided up into study areas. Those study areas were determined by environmental criteria, topography, and major roads. And you can see here we ended up with 18 study areas for the CWMP. And certain parcels were removed from the analysis due to protections. Basically, any development or future wastewater needs would not need to be considered. Those were protected open spaces, town forests, parks, etc., non-developable areas, and town-owned land. So for those 18 study areas, we performed a wastewater needs assessment. Essentially, we want to see what might be the best solution for wastewater disposal in those areas for the next 20 years. This was a tier 2 analysis where tier 1 included primary criteria, which received more weight, and secondary criteria, which was less weight. The tier 2 part of the analysis was a more holistic approach where we consider any other factors like if a parcel is repeatedly has a failing septic system or requires a lot of pump outs or something like that, which may not show up in the tier 1 analysis. And we wrap all that into a needs area analysis with grading. So for the 18 study areas, we did this type of grading for each one. We've pulled out and highlighted the 4 study areas that received the higher scores and moved on to the future phases of the CWMP. You can see at the top of the table, primary criteria on the left side was weighted from a 0 to 10 point scale, and secondary criteria was on a 0 to 5 point scale. The primary criteria consists of major items that would affect on-site septic systems, essentially. So soils and drainage class, depth to water table, depth to bedrock, parcel size, and whether a private well, water well was on the property or not. We grade each and subtotal them up. We then look at the secondary criteria, which consisted of drinking water protection districts, impacts from sea level rise, floodplains, estimated habitat areas, and historic districts. We subtotal those up and add the scores together. Anything that received higher than a 30 was considered a high needs area. And what that means is essentially on-site septic systems may not be the best wastewater solution over the 20 years, and we need to look at them further. Area 6 actually received slightly lower than the 30, but when we were reviewing these scores with the city, they actually pointed out that Area 6 had quite a few tight tanks, so not your traditional septic system, and failed septic systems in the area. So we actually carried that forward into phase 2 as a high need. So these areas in red are our high needs areas. We have up here in the north, area 2, which is the Wingersheik Road area. Area 6, which was Atlantic Street. Area 9, Causeway Street. And area 17 down here in the south, which was the Hesperus Avenue, Magnolia neighborhood area. So we take all the information from phase 1 and we build upon it in the later phases. Phase 2 is primarily those high needs areas. So those 4 areas I just mentioned in red, they move forward into phase 2 to identify alternative treatment methods. And then we shortlist those alternatives, which will proceed into phase 3. So what are the other options available for properties with on-site systems? You have your traditional septic systems, as I've explained earlier. We also have innovative alternative on-site systems, which really are a more advanced treatment system directly on the property and typically removes stuff like nitrogen or phosphorus from the wastewater. So additional treatment than just your typical septic system. You can also have decentralized systems, which could be like a cluster neighborhood shares a large septic system or IA system, or maybe a larger neighborhood puts in a new sewer collection system and then sends that flow to a new small wastewater treatment facility. You can also extend the existing city collection system, and there's several options there. Traditional gravity sewer, low pressure sewer, which there's a few locations in the city with that, and vacuum sewer systems. So again, this is a figure of your typical septic system. You can also have a mounded septic system. So maybe you have shallow depth to bedrock or groundwater, and you need more area built up on your property. So you have a large hill or mound for that additional area for treatment. There's several IA, again, innovative alternative systems. These are all regulated by Massachusetts Department of Environmental Protection, MassDEP. They have an approved list of technologies that apply as these IA systems. Some of the options are the BioClear, Amphidrome, FAST, RUC, and EnviroSeptic systems. We've shown here a figure of the BioClear system, where essentially there's additional settling and then a biological filter for additional treatment before discharging to groundwater. We then look at the decentralized small wastewater treatment plant alternatives. There's several popular options in the Northeast in particular, in the form of rotating biological contactors, sequencing batch reactors, and membrane biological reactors. You usually see these in like condo associations or apartment communities. And again, these typically provide higher levels of treatment than even an IA system does. This would be a full new construction of a facility and collection system, so these tend to be pretty expensive to construct. Then look at the wastewater collection system extension alternatives. Again, the normal or conventional system is made up of gravity sewer, pump station. So for the low-lying areas that can't flow by gravity to get to the wastewater plant, need to be pumped, and that pumps through a force main, which then gets back to gravity sewer and gets to the wastewater plant eventually. You can also have a low pressure system, which we actually show here, one of the options for those on the left, where each property in a low-lying area could have a pump station on the property, and flow would come from the building into that pump station. It would then pump to the main existing collection system. You can also have vacuum sewer systems and small diameter gravity sewers, which aren't very typical, and we won't touch on those. So similar to phase 1 needs assessment, we do a 2-tier analysis for the alternatives for each high needs area. We've pulled out an example for area 6. We do a higher weighted primary criteria scored from 0 to 10, which consisted of level of treatment, ability to remove nutrients, land and site requirements, capital and construction costs, and ease of operation. The secondary criteria scored from 0 to 5 points consisted of public acceptance, regulatory requirements, legal requirements, operation and maintenance costs, such as annual electric costs or chemical addition requirements, and environmental concerns. And we take that for each alternative, so the on-site conventional septic and IA systems, decentralized, shared septic and IA systems, and small decentralized wastewater treatment facilities, and also the collection system extension options. We score those, add them up, and the lowest scores move forward into the phase 3 analysis. So you can see here, we've identified the conventional septic and IA systems, and also extending the existing city collection system or viable alternatives for Area 6. So at the end of phase 2, we concluded that for needs area 2, the Wingersheik Road area, conventional septic and IA systems were viable alternatives and should move forward into phase 3. Decentralized and collection system extension was not shortlisted and did not move forward. Needs area 6, 9, and 17 all had conventional septic and IA systems and city collection system extensions shortlisted alternatives that move forward into phase 3. I will mention that typically decentralized systems score high due to their initial capital costs and operation and maintenance costs. And they also require land purchasing and permitting, and a lot goes into them. So they typically score themselves out as options. So then we move into phase 3. Phase 3 is the ultimate recommended plan for each item we've looked at. So first we'll look at those 4 needs areas and finish the analysis on the shortlisted treatment alternatives. Then we take a look at the collection system, any infiltration and inflow removal, II control, as we call it, recommendations, pump station evaluations and recommendations, and the water pollution control facility evaluation. So we'll start off with those 4 needs areas. Needs area 2, Wingersheik Road. Again, the shortlisted alternatives from phase 2 were septic and IA systems. The area is in the north central western part of Gloucester, consisted of just under 300 acres of land and 66 parcels. And the soils in the area varied between very good and very poor, depending on how close you were to a surface water, wetlands, and also consisted of densely packed small lots. So part of the phase 3 analysis is cost estimates for each of these alternatives. And how we set up these cost estimates is we look at every parcel in the study area and we say everything with a building, not on sewer, so it has a septic system, we assume every parcel needs to be replaced over the 20 years. And we average that value over those 20 years and come up with an annual cost. We assume that the operation and maintenance cost for a septic system is basically the pump out required every 2 years. And then we add those to present worth costs to get a total present worth. Similarly, for the innovative alternative systems, we assume every septic system is going to be replaced with an IA system over the 20 years, spread the costs out evenly. And then For the O&M costs, operation and maintenance, typically those systems require more electrical, chemical, et cetera. So you'll see that cost is quite a bit higher. So for area 2, the total present worth for septic was just under $27.4 million. And for IA systems was just over $55.1 million. It's important to note that these costs would all be borne by the homeowners because there's no involvement from the city as a whole. This is basically the homeowner needs to replace their own system on their property. Next, we'll look at area 6. So Atlantic Street, the shortlisted alternatives were septic and IA systems and extending the city's existing collection system. This needs areas in the north central part of the city, contained just over 1,200 acres and 280 parcels. Again, the soils in this area were somewhat poor and there was high groundwater depending on how close you were to surface water areas. So because extending the city's existing collection system was one of the alternatives, we did a high-level analysis of what that piping network would look like in the area. So you can see down here at the bottom of the page, this is where the city's existing collection system is and where the area would connect into. The red line is the area extents. The orange line is gravity sewer, which we basically just followed the roadways into each neighborhood and home. The yellow, orange, oops, sorry about that. Orange boxes are pump stations we assumed would be required based on topography. So you can see here there's 4 required for area 6. 2 of them are in the area itself and 2 of them are outside of it, but required to actually pump to the existing collection system. We take this figure and we actually estimate costs based on length of pipe, size of pipe, how much trenching and paving is required, what the pump stations or how many pump stations there are, etc. So for area 6, septic system present worth costs were just under $12.3 million. The IA system costs were just over $24.8 million, and extending the collection system was actually right around $28.5 million. And for these costs, extending the collection system costs, these would not all be borne on homeowners like the septic and IA systems. There are funding opportunities in place for projects of this size, but some of that cost would be recovered through the betterment fee, which would be covered by the homeowner. So needs area 9, Causeway Street. Again, the shortlisted alternatives were septic and IA systems and extending the existing collection system. This needs area is in the central part of Gloucester, just under area 6, consisted of 335 acres and 180 parcels. The soils in this area were moderate in terms of their drainage ability, and groundwater depth was mostly greater than 3 feet. This area in particular had impacts from sea level rise and had a pretty densely populated small lots. So again, we mapped out the collection system that would be required to get wastewater flow to the city's existing collection system. You can see this part here is actually shared with what we identified as being required for area 6. These 2 pump stations are the same, essentially. The orange, again, is gravity sewer, and this purple line over here is actually what we identified as low pressure sewer. So this area to the right, as you get closer to the water, was actually low lying, and would require pump up to get to gravity based on topography that we reviewed. So the septic system costs were just under $8.4 million. The IA systems was just under $17.1 million, and extending the collection system was just over $23.8 million for present worth. Finally, we'll look at needs area 17, which was Hesperus Avenue. Again, the shortlisted alternatives were septic and IA systems and collection system extension. The needs area is in the southern part of Gloucester in the Magnolia neighborhood, consisted of 3,200 acres and 1,100 parcels. The soils in this area were moderately well drained, and groundwater depth was generally greater than 3 feet. But again, this area was impacted by sea level rise and small, densely packed lots. So we mapped out the collection system that would be required for this area. There are 2 pump stations in the area and then 2 more outside of it that would be required to pump up to the existing end of city collection system up here slightly to the north. The septic system costs for needs area 17 was just under $37.3 million. The IA systems were just over $78 million, and the collection system extension was just over $74.4 million. So based on our cost estimates, based on several other factors like environmental concerns, legal concerns, desire for sewer, etc., we came up with our recommended plan for each of these needs areas. And basically for all 4, we are recommending the city stick with conventional septic systems for the 20-year planning period. No collection system extensions were recommended. So we've discussed the unsewered areas of the city. We'll now jump into the existing sewered area. And the first part of that, we'll look at the pipes in the ground, so the collection system itself. The primary driver for looking at the collection system is capacity and also condition, how old the system is. Capacity issues can evolve into the form of a sanitary sewer overflow, as you can see in this picture on the left, where wastewater comes out of a manhole in the road. You can also see that in the form of wastewater backing up into your basement, for example. The primary driver behind these SSOs, the sanitary sewer overflows, is actually infiltration and inflow, II. So as clean water is getting into the system, it's more water than the pipe can handle, and the water needs to go somewhere. So the city's been very proactive in identifying and studying II in their system, and we'll talk about the work they've done to date and how that impacts their system. Before we jump into the II portion, we wanted to understand not just the existing sewered area, but what of that existing sewered area is not connected. So what buildings are in the area but not actually connected to sewer, and what parcels in that area are not actually developed yet. And we want to understand that to understand how much more flow could potentially be added in the future and would be required to be treated at the water pollution control facility. So how we do that is for the existing flow. So all those buildings in the sewered area that have a building now but aren't connected, we assume, based on industry standards, a 70 gallon per day per person flow rate and a Gloucester specific metric of 2.27 persons per household. And basically we look at the number of households, or whether it's commercial or industrial, and estimate a flow for that portion. And we also do the same exercise for what we call future build out flow. So any of those buildings, any of those parcels that don't have a building but are in the area. So again, we take the 70 gallons per day per person, the 2.27 persons per household, and then we take a look at the worst case development scenario based on zoning. So let's say the parcel is 3 acres large. Well, we're not going to assume only one building is going to come out of that parcel. We're going to assume it's going to be subdivided. And we come up with that worst case scenario. So what we estimated was for the existing buildings that are not connected, that are within the Seward area, about 0.13 million gallons per day of flow could be realized. The future flow within the Seward area could be 0.12 million gallons per day. And if we look at the water pollution control facility, their average daily flow currently is actually 3.75 million gallons per day. And if we take a look at how that compared to their permitted limit, which is 5.15 million gallons per day, we can understand that there's available capacity at the water pollution control facility, or additional flow could be added in the future, and that amounts to 1.15 million gallons per day. If the city were to choose to increase their permitted flow from that 5.15 to the optional 7.24, they'd have an additional 3.24 million gallons per day available capacity on average. So especially in New England, a large portion of a wastewater treatment plant's flow that's received, especially in the high groundwater periods or rainy seasons in the spring and fall, is actually from infiltration and inflow. So infiltration is, water that can get into the pipe from groundwater through cracks and holes, breaks, things like that. And inflow is basically rainwater that can get in through like a sump pump connection. The city's been very proactive throughout its history to identify and reduce II in their collection system. And we'll talk about the work they've completed to date. Also the 2 reports, the utility master plan and asset management plan, and II studies that have been done, and recommendations and cost estimates coming out of those. So the city's II control history, in 2017, New England Civil Engineering Corporation completed an II study, and part of that study was actually to do flow monitoring throughout the collection system. In 2021, the asset management and utility master plans were completed by Wright Pierce, and basically II removal and SSES work was performed, which identified basically options to reduce II in the system even further. And that consisted of replacing sewer pipes and manholes. An abandoned sewer was discovered and plugged on Rockland Avenue, and about 47,400 feet of drain and sewer pipes were CCTV'd, or basically a camera was put in the pipeline and cleaned. Some of the recommendations coming out of the work done in those 3 reports were additional II reduction improvements, actually doing routine CCTV, again, camera, pipe and manhole inspections, 1-year flow monitoring, updates, and expanding the city's existing hydraulic model, continuing to do SSES projects and routine operation and maintenance within the collection system, and additional SSES work was identified to further identify sources of II in the system. Some of the tasks coming out of that work and the costs associated are shown in this table. Some of the highlights, sump pump disconnection policy. So, some pumps in basements could be connected to the sewer. We really don't want that clean water in the system because it's basically you need to pay for the treatment of clean water that's already, fine to be discharged outside, for example. Routine CCTV pipe and manhole inspections, flow monitoring, all totaling just under $3 million for that additional work. And these costs are actually presented in 2022 dollars. We did update these for the CWMP based on the recommendations in the utility master plan and asset management plans. Next, we'll jump into the pump station evaluations. So those 29 pump stations in the city, they are constructed and they've been upgraded in various years, expanding, back to the original inceptions. Each of those stations, we performed a condition and criticality assessment as part of the asset management plan. We developed a capital improvement plan, and as part of the CWMP, we did update those recommendations based on work the city had already completed between the finalization of the CWMP and the publishing of the asset management plan. And we also updated the cost to 2022 dollars. So again, this figure identifies where the 29 pump stations are within the city. And for each of the 29 stations, certain recommendations were made based on the condition or remaining useful life of equipment, for example, and ultimate costs were placed for those. Some of the stations were completely replaced between the publishing of the asset management plan and the CWMP. So those 4 stations are actually not on this list. For more detail, please do look at phase 3 of the CWMP or in the appendix, the asset management plan for the full breakdown of what's contained in these. But essentially, it's about $5.2 million worth of work. The asset management plan broke up the 29 station recommendations and their costs and applied them and spread them out over a 20-year planning period for a capital improvement plan. You can see here we have 2023 to 2042 based on the CWMP, but the asset management plan was actually completed 3 years prior. So the costs are spread out over the 16 years in this case, with an average yearly cost of around $260,000. So finally, we will delve into the water pollution control facility evaluation. The original evaluation was actually completed at the same time or around the same time as the utility master plan and asset management plan in 2019. And we did update it, certain items that have been completed to date and costs to 2022 dollars during the CWMP. I will mention that again, we are going through this relatively quickly for the presentation. If you are interested in more detail, please do look at the phase 3 CWMP report, and the entire 2019 evaluation is included in the appendix in that as well. So the water pollution control facility was constructed in 1980. And again, at the time, the city and the facility received a waiver from the EPA for their NIPDES permit that only required primary treatment. Some work that's been done since the original construction, major upgrades in 2009 and 2011 added a new headworks facility, sludge pumping systems, and a new sludge dewatering system. Recently in 2021, there was a disinfection upgrade, which resulted in a whole new building that houses chemical storage and feed. And currently in 2022, there's actually a flood barrier that's in design that would encompass basically the entire site to protect it from flood, sea level rise, etc. So what's the driver behind the 2019 evaluation and this CWMP as it relates to the treatment facility? The biggest one is the NIPDES permit. So again, the original NIPDES permit had a 301 waiver, which basically stated that it's okay for the facility to only have primary treatment, and the flow limits associated with that permit, average daily flow of 5.15 MGD and a peak design of 15 million gallons per day. Recently, effective just a couple of weeks ago, September 1st, 2022, that 301 waiver was removed in the permit renewal, which means secondary treatment is now required. As the existing facility is not set up for it, that means an upgrade is required. In addition to that, should the city choose to increase flow, so from the 5.15 to the 7.24 million gallons per day, this would require another upgrade, or as part of the secondary treatment upgrade, more equipment and tanks would need to be replaced. And that's because the existing system is primarily not set up for that much flow. So in 2019, the facility was evaluated by Wright Pierce. We'll look at the existing system first. Part of that evaluation realized a lot of the equipment and processes that are existing are quite aged and approaching the end of their useful life. Some of the highlights are the influent screw pumps were identified as requiring replacement, new ferric chloride system, repair to the primary clarifier concrete tanks, and also installing new mechanisms and scum removal systems in those tanks, new plant water system, and a new odor control system. The second part of the evaluation looked at, okay, what are the options available for secondary treatment? We know we have to do it. What are our options? So the evaluation looked at a conventional activated sludge system, which is shown here in the picture to the left, where you have these concrete tanks that are aerated, and the biology in the wastewater is allowed to perform treatment essentially. And then these are followed by sedimentation tanks, where those that biology settles out and is removed from the effluent that eventually gets just discharged from the facility. We also looked at conventional activated sludge without the existing primary clarifiers, sequencing batch reactors, which basically takes those aeration tanks and those secondary clarifiers and puts them all in one tank to save space, and biological aerated filters, which is a similar setup to these tanks, but within the aeration tanks, you'd actually have plastic media where a biofilm grows and allows for additional treatment to take place. So in 2019, we looked at all the options for secondary treatment, and we identified this one potential solution, which was identified as maximizing the capacity for treatment. So not the only solution, but we have here a layout of the site on the left. You can see this blue line here is actually the flood barrier that's proposed. You have in orange the aeration tanks that would be constructed, secondary clarifier tanks that would be constructed. And then as a result of this new secondary treatment system, you have a new biology, a new sludge that is formed and would need to be removed, treated, etc. And we've identified new buildings and equipment that would reside here to house those systems. Again, this is one potential option, not the only one, and would definitely be reevaluated during preliminary design of any upgrade. One of the key things to this upgrade project is with the aging systems, you'd actually have new covers for the primary clarifiers, which would actually remove, and a new odor control system, which would remove odors that would be emitted from the site, and secondary treatment as a whole reduces odors. So one key thing to keep in mind as we investigate these options during any design project for an upgrade. So based on the improvements identified, cost estimates were provided in the 2019 report. We updated those to 2022 dollars for the CWMP. We also took into account the inflation climate we're in now and COVID and supply chain issues we've seen, and updated those cost estimates. So the two key takeaways are the total construction cost, highlighted here, which is just under $76 million, and the total project cost identified here, which includes items like engineering fees, legal fees, financing considerations, etc., which is just under $97.6 million. And again, this is for this proposed solution, which maximizes treatment capacity for the facility, but may not be the ultimate solution identified for the upgrade. So what does a typical upgrade project look like in terms of schedule? We've identified a couple key dates that have already happened. So the NPDES permit went into effect September 1st. The owner's project manager, which is an engineering firm hired by the city to assist the city through the design and construction of a project based on the large project size. That selection has already been completed and environmental partners was selected. The next large step for the project, for the upgrade project, would be selecting the design engineer. And based on feedback, it's expected that that would occur by the end of the year, essentially. Once the design engineer is selected, they go through a pretty standard schedule for design and construction, or design bidding and construction. Preliminary design, which is a 30% milestone, typically takes 8 to 10 months. Final design, so that remaining 70% of the design and permitting, takes around 12 to 14 months. Bidding for a project this size would take about 4 months. And then construction could take anywhere from 24 to 30 months, depending on the ultimate size of the project and whether supply chain issues and things of that nature improve compared to how they are now. So in summary, we took a look at those unsewered areas within the town and identified the high needs for areas and the ultimate recommendation for the 20-year planning period is to continue with on-site septic systems for those areas. For the collection system and II control, for the pipes, the existing pipes in the ground, recommending continuing II removal, reduction investigation, addressing assets in need of repair, replacement, and rehab, developing a routine inspection program, and updating the hydraulic model. For the water pollution control facility, a major upgrade is required. That upgrade should address permit-related secondary treatment needs, age-related needs for the existing infrastructure, and condition-related needs for the existing infrastructure. With that, I will hand it back to Mark.
Thanks, Adam. So having a wastewater management plan in place, the city will need to develop a funding and financing plan in order to support those recommendations that have been laid out. It is assumed that for the water pollution control facility, the city will pursue SRF loan funding, which is state revolving fund loans through the Massachusetts Department of Environmental Protection's Clean Water Trust. Having a CWMP in place is just one of the pieces that would make the project potentially qualify for 0% interest loans through that program for the nutrient removal portion of the projects. And then otherwise it would be all the other remaining pieces of the upgrades would fall under their 2% SRF interest loans. The city is also eligible for principal forgiveness as part of that program, being a tier 2 as well as an environmental justice community. Going forward through the design, other grant opportunities could be pursued, such as the energy efficiency conservation block grants, which for eligible portion of the project would be eligible for grants for that and to help defray the costs of the projects. So with that, I'm hoping that people can raise their hands if they have any questions. Oh, I see one. Dana, you might have to do something to allow Robert to speak.
All right,
Hi,
Robert, ready.
Hi, this is Bob Myers.
Hi, Bob.
My question is two parts, both related to off-gassing. I saw odor filtration, but I didn't see any other references to that. The two parts are the pumping systems involved require a fair amount of electrical energy to run. And I'm wondering if there's any thought been given to somehow transforming any sort of off-gassing that occurs and fit it into something like a fuel cell or something like that that could perhaps cut down on the amount of electricity that we would have to pay for. And the second part is with the pumping stations, and I'm thinking here particularly about the Goose Cove Reservoir. I've been told that there's the off-gassing that I find to be very stifling when I walk by there is hydrogen sulfide. And that you can even see some of the vegetation proximate to the building that has withered away. And I'm wondering if there was any thought in the development of this that went toward cutting back on the emission of those gases, or if you didn't feel that was really necessary. Thank you.
I know for the treatment plant, what energy recovery for our methane was not looked as part of this evaluation, but I would think that the city might be open to that. Can't comment for them, but it was not as part of the CWMP. It was not looked at. And for Goose Cove, I'd have to look at what was recommended specifically for that station, and if odor control was part of the recommendations for that station.
We do have an odor control system at the Goose Cove pump station.
Okay.
So that would tell me that odor control does not address the concern I have. In
No,
other
it
words-
doesn't involve recapture of gas for energy, correct?
Or somehow breaking down of that gas. So it certainly there's an odor issue, but beyond that, there's actually an absence of oxygen that occurs in that area. So it's even more than just smells bad. It's actually it can stifle one's breathing. I've had it roll across Goose Cove into my house when my house was at the head of Goose Cove there. And actually one morning had trouble breathing. That was a long time ago, but I walk by it on a regular basis now and I smell it. So I'm not just talking about odor here. I'm talking about perhaps the gases themselves being very bad for a clean air or environmental concern.
Okay, thank you. Yeah, as Mark mentioned, we haven't looked into that as part of this evaluation.
So is it in line for me to ask that you do?
Yeah, Mark, I believe
Yeah.
is documenting all of the questions and concerns from this evening.
Yeah. So it'll be documented and responded to within the CWMP.
Thank you.
All right, thank you, Bob. I'm gonna go with Valerie next.
I'm sorry.
Valerie, looks like you're
Yeah,
muted. There you go.
You can hear me now. Yeah. No, I started to say thank you very much. I think one of the more striking conclusions you've already reached is that sewer extensions over in West Gloucester don't appear warranted, or even down into Magnolia. So that's pretty consistent with a lot of planning efforts in the past. I'd like to raise on behalf of a number of the climate change groups that I'm a part of, 3 questions that get talked about, and which you didn't necessarily address. So I'll just put them out there as sort of the buzz. One is that people generally understand that the current treatment plant is in a marsh, and it sort of doesn't make sense to them that the best solution is to rebuild in the existing area, or that just a seawall would protect that plant. And part of that is kind of understanding groundwater coming up or increasing levels of hurricane storm damage. And I know that EPA is increasingly looking even at 500-year storms. And so how much have these studies actually looked into the question of whether the long-term future of the plant makes sense in the marsh? I'm just saying that's what a lot of climate people buzz about. How can that make sense? And can you guarantee in the engineering work that you've done that somehow, in spite of the oncoming climate challenges and groundwater in particular coming up, that even with seawalls that are planned, that this is going to be a viable location? That's number one. The second question that a lot of people are talking about, since I'm on, why don't I just list the questions, and if you write them down, maybe you have some preliminary answers. Second question is the interest that has been expressed by the congressman and the state senator around looking at regional solutions, kind of particularly hooking in Manchester or adding more capacity from Rockport and Essex. And I wonder whether some of these regionalization questions have been part of your analysis so far, or how they could be fit in going forward? So that's sort of like number two. What about regionalization, which has gotten a certain amount of attention? And have you all looked at that? And then the third question is to follow up on Bob Myers, but actually even to amplify on that. How much of attention have you given to both? Again, let me just say, these are coming from the climate people in town. How much attention have you given to the efficiency of the proposed technologies? I gather that there's a lot of technology development about how to reduce energy use in treatment plants. How much have you looked at that? And then beyond that, what room do you see, or how could it be incorporated to look at some pretty innovative energy recovery out of wastewater and septic system and solids and other things? Some of us in the climate arena are aware of things like hydrothermal processing and other things that DOE and the Water Research Foundation are looking at. And so I wonder how much you could incorporate some of the more innovative technologies in energy recovery. So how are you looking at the long-term viability of being in a marsh? Is the seawall sufficiently protected? Have you looked at all, or could you, at regionalization opportunities? And then the third one being, there seems to be a lot of progress on energy efficiency and also waste recovery technologies. And how do you see that those kinds of innovative or fairly, how much have you looked at it, at the best practices around the country at maximizing out on reducing carbon emissions, and indeed maybe even looking at recovery of energy in these wastewater flows? So those are the three areas that people are buzzing about and would really appreciate ultimately some answers on.
I don't want to thank you, Valerie, for your questions. I don't want to, I don't have an answer for number one right now about the climate change and the flood barrier and all that, but I can say for the questions 2 and 3 for the regional solutions, and for number 2, regional solution was not part of our scope for the CWMP at this point. And then for really diving into energy efficiency and looking at different technologies and all those, that would really come into a preliminary design portion of the project if the city was looking to pursue those type of those topics. So for the CWMP, no, those were not looked at.
Could you see those as fairly easily incorporated, or which ones are? I think one striking thing was the schedule that you're talking about. It seems like the designs that you put forward are pretty much on a fast track. One other thing I would say from the climate arena is some of those pump stations are clearly near the coast and likely to be flooded, and probably it makes sense to elevate those. You know, has that been included in your cost estimates or prioritization? These are all questions from, you know, climate change is coming. Yep. And has the city infrastructure really incorporated fully what's going to be happening, and what's your view on that, or what are the answers to some of that?
I'd have to go look and see if I don't know the specifics for the pump stations, and if flood control measures were included in those. I don't know if Dana and Adam know offhand.
You know, it's a case by case basis. I will say we're doing 2 SRF funded pump station upgrades this year. Both of them are taking into account flood controls and measures for climate change, sea level rise. So resilient design is part of any upgrades we do to infrastructure. So
Yeah, thank you for that. I was really struck that EPA is looking more and more at 500-year storms even. So I think the pressure is going to be increasingly on for responsive and resilient infrastructure. So anyway, thank you for taking my questions. And I gather you will respond in more depth in writing. So thanks for that.
All right, thank you, Valerie. I'm going to move on to Paul. Paul, looks like you're muted.
There, does that work?
Yep.
We can hear you.
Okay, thank you. Paul Romery. I live downtown Gloucester, involved with some other capital investment issues in the city. So this has been a very informative presentation. I won't prolong this, but I had a couple of questions. One, I didn't hear any mention of the outfall pipe and whether there's one, been an evaluation of its condition, and two, whether the addition of secondary treatment changes what goes into the ocean. And whether there isn't any way of looking at repurposing some of that water as gray water for topical applications or whatever. That's one set of questions. The second is, when you were looking at the 1 million gallons per day capacity and talking about potential increase to something like 5 million plus per day, is that just a theoretical discussion, or is that because you are thinking there's an opportunity here to expand the plant's capacity? And if so, does that analysis also look at the ability of the city to provide that much water to residents and ultimately users of the sewage plant? As we've learning the hard way that drought can be a recurring condition. And then on funding, I know it's not your purview, but looking at sort of the timelines involved here, can you speak generally to whether there are options the city can pursue that were made available during the pandemic, or infrastructure funding that can reduce ultimately the cost to the ratepayer? I'm sure there's people looking at this, but I didn't hear any mention of, is it a 20% or 60% chance of getting external funding sources to reduce some of these costs, or is that something somebody else will have to speak to later? Thank you.
Yeah, I think when it comes to funding, we'll see how things play out. I know the city is positioning themselves to receive low interest loan funding through the SRF program, which also includes principal forgiveness. And I'm sure they will they'll also be looking at grant opportunities as well. But as far as any sort of percentage or likelihood of receiving those, I can't comment on that.
Okay. Then in terms of the outfall pipe, and where does the water go? Is there any difference in water quality being sent back out to the ocean? Can it be kept on land?
So the addition of secondary treatment will improve the treatment capacity of overall treatment of what is being of the plant effluent. As far as the reuse or any gray water type systems or anything like that, that was not part of our scope for the CWMP.
And then in terms of expanding the MGD capacity of the plant, is that a theoretical discussion, or is that because there's an opportunity here, or?
So we looked at each of the sewered areas, and it's theoretical at this point. We looked at the sewered areas. If there was not a building, or if a parcel was not currently connected to sewer, what would ultimately, if those areas were built out and connected to sewer, that was the increase of that. Totally, it was 0.25 MGD. The plant is currently permitted at 5.15 MGD.
Mhm.
But if they were to once they install secondary treatment, but it also requires capacity upgrades throughout the treatment facility, then they could bump it up to 7.25. But that's as far as looking at if the water distribution system can handle that, it was not part of the scope.
Okay,
So that's expanding the plan is twofold, both secondary treatment and having capacity upgrades.
okay, thank you. This helps establish a little more context.
Thank you, Paul. All right, Pamela Steele. I'm giving you permissions now.
Hi, I just had a yes or no question. Was your firm hired to look into how and why the creek on Good Harbor Beach was polluted recently? I mean, they recently hired a company to look in.
No, it was not. Nope.
Thank you.
Thank you, Pamela. All right, I'm seeing Mary Ann.
Thank you, Mary Ann Boucher. I heard effective on 9/1/2022 that the waiver from the secondary treatment plant has been removed. Thus, we are now mandated to upgrade to a secondary treatment at a cost of 97 million. It was also said that the plant is currently designed to hold 5.1 million gallons per day, and that any increase would require an upgrade with new pumps. But it wasn't discussed at what kind of a cost it would be to our city if you were to upgrade to 7.2. Has that been discussed? And if so, what would that cost be to the city? Thank you.
Capacity upgrades were not included in our cost estimate.
So how will we know if and when that's a possibility?
It's a bit of a nuanced question because the plant design capacity is larger than what the actual plant output is. I think we'll have to provide more detail in the written answer to your question. But plant upgrades per the secondary treatment, I think would also potentially serve the additional capacity allowable.
Right, but we still don't know the cost of that. Could that be another 97 million? Could it be 25 million? I mean, it's adding quite a bit of additional usage. So I mean, you have this presentation and you're saying that they could possibly increase to 7.25. If that's the case, then there's a giant leap in the amount of the cost of this project, correct?
I don't think that's necessarily true, and that's outside the scope of this plan, this comprehensive wastewater management plan. But we'll provide a written answer to your question.
Thank you.
All right, thanks, Mary Ann. Next, I see it's an email address, Olympia57.
Hi there. My name is Olympia Palazzola, 57 Western Avenue in Gloucester. I have a question because almost all the answers that you're giving to people is, it doesn't pertain to this plan that you have. How long ago was this plan started, and is it almost out of date before you're getting to the end of it? And telling us all of this. We're in the process of talking about, and I'm going to call it MBTA because I don't know it by any other name. And the fact that they want us to add 3,000, and I don't have the exact amounts, around 3,000 more units in Gloucester that are all downtown, so they'd all be on city sewer. Is this plan that you're discussing capable of taking on that many new units in the downtown area that would all have to be sewered? That, you know, that's becoming a concern because not only sewer, it's also water. And can you address that, whether it's already been included in your new plan?
I could say that it was a specific MBTA development downtown was not, or a requirement or for additional housing units downtown was not included.
Thank you.
So.
All right, I don't see any additional questions.
Nope.
Oh, is there one?
Yep. Valerie.
Oh, Valerie. Valerie, there you
Yeah,
go.
I thank you. I just have one more question. I think I was a little surprised at how soon all this is supposed to come together. It's by December. Number of people have raised issues around MBTA zoning capacity, or the ones that I raised about regionalization or in the marsh and whatever is. It would be probably really useful if you all could explain a little bit more why there's an agreement with EPA and then there has to be a rush to what you've explained is a fairly circumscribed plan by December. And could that be extended in order to take a little bit more time to look at, especially the one about capacity, as if other communities like Manchester could be added in, or if there are more housing units or whatever, that those cost estimates, as the last questioner asked, seem to be really important. So could you talk a little bit about the schedule, and is it necessary to, in a couple of months, settle on a plan that is not addressing some of these other factors that have been raised?
So the schedule that was presented in the presentation, is a typical design build build schedule for a typical project of this. Is not specifically laid out for Gloucester. It's just a sort of typical time frame. And by December, it was only to bring an engineer on board to start doing the preliminary design. So, I mean, nothing presented here is it's only recommendations at this point, and there'll be definitely be updates to cost estimates and scope of the project as things are moved forward.
Oh, I appreciate that. That's probably good news for everyone.
Right, Dana, you agree with that, right? Or
Yes, and a lot of these, you know, like advanced treatment techniques, those sort of discussions need to happen with the selected designer. So that's the rush to get a designer on board.
yeah.
Well, and I have heard the regional questions, and certainly the DOE is helping municipalities around innovative waste recovery. And so some of these, with that extra time you're talking about with an actual engineer, that's, I'm happy to hear your answer. Thank you for that.
Yeah, this is a planning document to move forward. It's not, nothing is, it's all recommendations, that's all.
It's not set in stone. Appreciate that. Thank you.
And I don't want to misspeak, but I tried to allude to it earlier. There's a difference between the design capacity of our plant versus our permitted capacity. And I believe the design capacity is sufficient for future growth as is. So secondary upgrades, this planned plant upgrade includes treatment improvements, but the capacity of the plant is already sufficient, if that makes sense.
No, but I think, Manchester is in some trouble with their treatment plant below sea level, actually. And I think they're looking to see some consideration of potentially they're paying for a sewer trunk line up to the treatment plant. And I don't know what their flows are, but I think they're concerned about capacity and similarly for Rockport. So if you added all the regional questions in, that number might be to go up. Now that I'm thinking about it, actually, and I certainly don't know the answers to it, but I do know that a lot of people are asking about processing on the harbor. The perception has been that there are limits on shipping blood and other stuff in the sewer pipes, and there have been some caps on that. I think an answer to a question of will this upgrade help support additional seafood processing on the waterfront? And just maybe some answer to that would be of interest to a lot of businesses and advocates of the working waterfront. Thank you for that.
I'm gonna note that question. I can't respond to that. So.
I guess it has to do with the quality of what would be put into the sewer pipes and how the treatment plant can handle that presumably better. And I think we may be under our current limits for that. But anyway, those who would like to have more processing come back into that the problem with reducing seafood processing in the waterfront came when treatment standards made it virtually impossible for them to do on-site treatment. So any increased capacity based in the new treatment plant to have more expansion of the seafood processing sector would be of a lot of interest to a lot of people.
Thank you, Valerie. I see another attendee with some questions, so I'm going to move to Beverly. Beverly, you're muted. There you go.
Okay. I have a very simple and basic question because I'm not a professional in anything to do with engineering. But the issue of the barrier that you suggested that would be surrounding the plant, I wondered if this particular barrier, I don't think we really have too many details about how it's constructed, but has it been proven to be effective in other cases like this in a swamp or a wetland? And what kind of a track record is there? How many years does it last? And really, basically, has it been proven to be effective?
We're not the engineer for that, so I don't want to comment on the flood barrier.
I can comment briefly on the flood barrier. Flood barriers have been effective internationally. There's no unique technology that's being used here. The design includes a masonry flood wall, some sheet pilings, a berm. all tested and reliable barrier methodologies.
So they've been tested in a wetland, and what about water level rise? Would it stand up to that?
Yes.
Okay.
All right, Beverly, if that's it, I see another question. So I'm gonna give permissions to Mellow Art.
Hello, my name is Melody Phaneuf. I'm at 3 Centennial Ave. And I'm just curious. I know we're talking a lot of money, and I'm always concerned that this provisos, we're not quite doing it right. So here's the question. If money were absolutely no object, what would it cost to move that plant right out of there up to higher ground and start from scratch? Any clues on what kind of money we're talking about for that?
I don't.
Okay, who would know the answer to that question? Is that an engineer question?
Yeah, Melody, that's a great question. It would probably, we'd have to hire an engineering firm to do an evaluation on that. Because there's a lot that would go into it, as you know, right? Like moving it and then moving the whole collection system to flow to this new location. So yeah, it's a great question. It would be its own study to figure that out.
If you had to guess, do you think it would cost twice as much, 3 times as much, 10 times as much? This is just a guess. I'm not holding you to it at all.
Well, the video is the video
yeah, the public record is holding me to it.
Oh, so you don't even have a guesstimate. So if a city or town is starting from scratch, it's all an individual circumstance that you have to do an estimate of the particular circumstances. Is that how it works?
Yes, yes.
Okay. Gotcha. All right, I thought I'd ask.
Like I said,
Thank
great
you.
question. Thank you. All right, Beverly's got another one, so I'm going back to Beverly.
No, all I did was mute myself, but I guess I should have lowered my hand. Sorry.
Yes, that's okay. All right, thank you. Okay, don't see any other hands raised. Oh, Valerie.
Yeah, just to clarify on some of those last questions, I think what is counterintuitive about the marsh is that you can put up a seawall, but has anyone looked at groundwater from below coming up and flooding those systems? Because certainly that is a factor in many places, is being understood. So that's a little bit different from the effectiveness of a seawall and a berm, which I think people can get. So I'm just kind of trying to report into you this sort of counterintuitive notion that you can actually rebuild something in a marsh and have that sustain the challenges of storms and sea level rise and groundwater infiltration. So I think any answers to those kinds of questions would really help the community understand why the suggestion is to keep it in the same location. It sort of runs counterintuitive to how people think about this. Just to amplify on
Sure.
what people talk about.
Sure. As Mark mentioned, right, Pierce is not the designer of the seawall. And I'm certainly not the technical expert, so I think we'll have to defer answers for now.
Yeah, thank you. Appreciate it.
Right. I don't see any other questions. So. All right. Well, thanks everyone for attending and asking some great questions. And we've recorded all those questions and they'll be included in the final CWMP. Just a reminder that all 3 phases are currently on the city's website, and there's also physical copies at the City Hall Annex building. So thanks everyone. Thanks, Dana.
Thank you, Mark. Thank you, Adam.